So hello guys, welcome back to the LeetCode series where we are going to solve the LeetCode problems. So now we'll solve a problem called 2 sum 2 input array is sorted. So we have solved a 2 sum problems. So this is a variation of the same problem, but this time we are given that the input array is sorted. So the earlier approach we did was of creating a dictionary and then traversing over it and finding a complement, and once we find the complement of it we just return the index. So you could use that approach as well, there's no harm in it, but this time since it's given that the array is sorted, we could use a two pointer approach. So a two pointer approach is where we create two pointers, one at the starting of the index and the second at the ending of the index, and we increase or decrease the value of our pointers. So let's get back to the question. So it says, given an array of integers that is already sorted in ascending order, find two numbers such that they add up to a specific target number. The function toSum should return indices of the two numbers such that they add up to the target, where index 1 must be less than index 2. Okay, so we need to return answer. Both index 1 and index 2 are not zero based. Okay, you may assume that each input would have exactly one solution and may not use the same element twice. So okay, so let's see the example. So we have uh, 2, so you can see that this array is already sorted. So this time we are given that the indexing is not zero based. So what that means is that this time we'll not start with 0 1 2 and 3. We'll simply start with 1 2 3 and 4. So 1 2 3 4 are the indexes, and we'll need to find the two pairs whose two indexes whose sum targets is equal to the target value. So here index 1 is 2, index 2 is 7, and when we add 2 and 7 we get 9, which is our target, and hence we return a list which has index 1 and 2. Next example, we have 2 3 4 already sorted in ascending, and we return 1 comma 3. So 1 comma 3, which is 2 plus 4 6, and in this we have minus 1, so we return 1 and 2. Okay, fair enough. So what we can do is probably we'll try solving this not using dictionary this time. We'll use the two pointer approach. So what two pointer approach does is, so let's say I have this array 2 7 11 and 15. What I'll do is I'll have a start pointer which will be at my first index, and an end pointer which will be at the last value in the list. So what I'll do is I'll add start and end values, and if this value, so for example it's 17, so the sum of 2 and 15 will be 17, and if this 17 is greater than my target, so my target is 9 and it is greater than 9, 17 is greater than 9, so what I'll do is I'll uh, decrease my end pointer and will shift my end point towards left. So now 11 will be my end pointer. Now again I'll add 2 and 11, which is start and end. I get 13, so this will be crossed. I'll add 13. 13 is greater than 9 still, so again I'll cross this, and what I'll do is I'll shift this to here, and my end will be here. So now when I add 2 and 7 I get 9, and now since it's equal I'll return the index 1 comma 2. So this is a way we can do this, but one more condition is, for example, if let's say we have, so let me remove all this. Okay, so let's say our solution which we were given was uh, we had a target equal to 22, and now when I add start and end I get first 17. Now 17 is less than 22. So in this case what I'll do is now I'll shift start pointer towards left, because we know that now if we include 2, we'll not be able to get the solution because we are adding the smallest number with the largest. So we know that okay, if we add these two we are not getting the answer, so we need to increase the smallest value now. So I increase my smallest value to 7, and when I add 7 and 15 I get 22, and I'll return 2 and 4. So this is the approach we are going to follow, and let's code it now. Okay, so what we'll do is we'll create a start pointer which is set to 0, and we'll create a end pointer which will be equal to length of my nums array minus 1, because here you can see that it's the length is 4 and the last index is actually 0, 1, 2 and 3. Okay, now we go to a loop where we write while, and while start is less than end, what we'll do is so this condition is basically for checking. So if my start pointer goes from, so let's say my start pointer is at a point here and my end pointer is at a point here, so I don't want my start pointer to go over here and my end pointer to go over here, because what it will do is basically just negate the answer which we had earlier. So we don't want this. We'll iterate over all the elements by the condition where our start pointer is less than end. If it goes ahead of the end, that means we don't have any specific answer, or we don't have any answer in the array. So that's why we have written start is less than end. So now we'll write if nums of start plus nums of end is greater than target. So if we add two numbers and it is greater than target, we'll decrement the end value by 1. Similarly, if nums of start plus nums of end is less than the target value, my start will be incremented by 1, and else part, so here else part will be that if we add start and the end pointer and it's equal to target, then we'll just return a list which has start and end. But remember that we have coded a problem according to zero based indexing, so we'll need to add +1 to the start value and end to the start value. So this is a solution for the problem, and let's try to run and see whether I have written it correctly or not. So okay, it's written correctly. Now when I submit it, so okay, it's submitted and our runtime is 64 milliseconds and 48.72%. So yeah, this is the solution for twosome where the input array is sorted. So try solving this problem by yourself. I hope I was able to explain the problem clearly and help you understand the problem. So that's it. See you next time.